The first is from primary alcohol and aldehydes. How we are going to prepare carboxylic acid from primary alcohol or aldehyde? It's very easy to prepare from aldehyde and primary alcohol. You can either take mild oxidizing agent or a strong oxidizing agent. It should be oxidizing agent. Like we can take K2Cr2O7 or KMnO4 in acidic medium. Then this aldehyde will be oxidized to carboxylic acid. This aldehyde will be oxidized to carboxylic acid. And if you have a primary alcohol, then you are going to use this strong oxidizing agent, and a strong oxidizing agent like either you are going to use KMnO4, K2Cr2O7, or either you can use Cr2O3 plus H2SO4. This reagent is known as Jones reagent. This reagent is known as Jones reagent. Then this alcohol, primary alcohol, will be directly converted into carboxylic acid. So it's very simple. If you are going to take primary alcohol with mild oxidizing agent, you will be getting aldehyde. And again, if you are going to oxidize that aldehyde, you will be getting carboxylic acid. But if you want to get directly carboxylic acid from primary alcohol, you are going to use a strong oxidizing agent and you will be getting directly carboxylic acid. Is that clear? Is that clear, everyone?
Yes.
Now the next one is from alkyl benzene. And this reaction is very important, from alkyl benzene. So from alkyl benzene, you know, this is your benzene and this is your alkyl part. So this is also known as, its common name is toluene. And if you are going to treat this toluene with oxidizing agent KMnO4 in the presence of base and then followed by acidification, this CH3 will be directly oxidizes into carboxylic acid and you will be getting benzoic acid. So please do write. And I'm going to give you a question on this. There is CH3 here. And then there is CH2, And if you are going to treat with the same reagent, you know what will happen? This will be oxidizes into carboxylic acid. This will be oxidizes into carboxylic acid. And this carbon, which is connected to the benzene, will be oxidized to the carboxylic acid. And this part will be eliminated because if you are going to make this carboxylic acid, this part, it will not be in conjugation with benzene. So always remember that if you are having this carbon which is connected to the benzene and there is one hydrogen, so you are going to directly oxidize this and the rest part will be eliminated. It's very important. Please do that. Can I change the slide?
So can you scroll up, please?
Scroll up like this. We started from here, Seth.
Yes, sir, done.
Okay, everyone done with this? So this is the second preparation of carboxylic acid. Now the next is from alkenes. These are very easy. You just need to take care of the reagent from alkenes. So if you are going to have an alkene like this, and you are going to treat this with potassium permanganate KMnO4 and heat it, you know what you need to do? You just need to break the bond between this and oxidize this into directly carboxylic acid. So on the right hand side, you can see only one carbon is there, and if it will be converted into carboxylic acid, you will be getting methanoic acid, which will have a formula HCOOH. And on the left hand side, you have two carbon, which will form ethanoic acid. So you are going to directly write the carboxylic acid formula with the help of the number of carbon. So if I'm going to give you this, can you tell me the name of the product? Am I visible?
Yes, sir.
Let me know the product in this. Oh, I need to tell you about the syllabus for upcoming exams. Any answer for this one? Mamuna, Hanifa, Alan, Hiba, Farhad, Aksa,
Ethanol and propanol.
propanol. You are oxidizing
Null.
into acid.
Yes, ethanoic acid and propanoic acid.
Yes. So you are going to break this. You can see on the left hand side, you have two carbon. So you are going to make it carboxylic acid, which is ethanoic acid. And on the right hand side, there is three carbon. So it will be converted into propanoic acid. And this is the formula for propanoic acid. So this is the third preparation of carboxylic acid. Now we are going for the fourth one, which is from nitriles and amides. Basically, these are connected. Actually, we will use nitriles, and nitriles first converted into amides, and then after hydrolysis in the presence of acid, you will be getting carboxylic acid. Let's say this is your nitriles. First, you are going to react this with water. That means hydrolysis of water is taking place. So what will happen? It's very simple. Oxygen will, the bond between these two will be broken, and this will form RC double bond O, and here it will form NH2. So this becomes amide, and after getting amides, you are going to do the hydrolysis in the presence of acid. So what will happen? There is H plus and OH minus. So this OH minus, you know that this is plus, this is minus. So this negative will go here, and it will become RC double bond O and OH, carboxylic acid. And the rest part is byproduct NH3. It becomes NH3 when it goes to. So it's very easy. Is that clear, everyone? So if I'm gonna give you this reaction, first you are going to do the hydrolysis. You will be getting A, and after getting A, you are going to do the hydrolysis in the presence of acid. You will be getting B. Let me know when you are done with this. So see, what will happen? This two bond will be broken and this will be converted into amide. First, it's converted into amide. There is N that I forgot to write. Sorry, night is night, right? So this is your amide, and after doing hydrolysis, you will be getting this part. So this is your butanoic acid, not butanoic acid. Basically, it is propanoic acid. Is that clear, everyone?
Yes, sir.
Yes, sir.
Now the next preparation is very important because it comes from Grignard. So from Grignard reagents. From Grignard reagents, if you are going to react this Grignard with CO2, since we need C double bond OH, so we are going to react this with CO2. As you know that oxygen is more electronegative element, so it will take electron from carbon. So there will be electrophilicity at carbon. And you know that negative, there will be and positive, since magnesium is a metal, electropositive element. And then it will be attacking this R, since it becomes nucleophile, it will be attacking at C. So if it will attack on C, what you will have, you know that R, oh, wait a minute. I'm going to write in this way. There is C and there is double bond O. And this O will become negative, and with negative positive will go. So Mg plus X. And this R just uh, attacked on C. And after this, you are going to do the hydrolysis, H, OH, and you know, this has negative. So this H plus will be going with this and OH minus will be going with this. So you will be getting directly RC double bond O, OH. And here it will be MgOHX. This is the byproduct. We don't need to deal with this. This will be converted into carboxylic acid. So on this, I am going to give you a question. CH3, CH2, MgBr. Just let me know the name of the product. This chapter, we have very little left in this chapter. After this, we are going to have amines, which is quite easy and a small chapter. Are you done with this? Okay, I have made a road map. Wait a minute. The roadmap of every reaction in organic chemistry. I'll just show it to you. Then I will send it to all of you. Let me know whether will you be able to understand it or not. Just wait a minute. How will I be able? Okay. Are you able to see the OneNote?
Yes, sir.
Okay. So are you done with the question?
Yes.
Just wait a minute. Any answer for this one? So see what will happen. I'm going to explain it to you. This will have negative, this will have positive charge, and you are going to move to this side. So there will be negative, this will be positive. So this will be attacking on this side. So C O negative it becomes, and double bond O is there, and this is attacking on this. So this will be CH2, CH2. And Mg plus also comes here and with Br. And after doing hydrolysis, you know that H plus will be going with this, and you will be getting propanoic acid, isn't it? Easy. Please do let me know. No one respond. I don't know why. Only Saf. Mamuna, Farhat, Hiba, Alan, Hanifa, Aksa. Okay, can I change the slide?
Yes,
Yes,
sir.
sir. Yes, sir.
Okay, thank you for responding. So if I'm gonna give you pH Mg Br, and I'm gonna react this with CO2. It's not necessary that in the reaction it will be written as like this. It can be written as CO2. So you have to do it in your own way. And then you are getting A. And after hydrolysis, you are getting B. Just let me know the name of the B. At least do at least one. What is pH? Everyone knows that it is phenyl, right? Yes or no?
Yes.
Okay. I'm giving you 1 minute. 1 minute is more than enough for this question. What is the name of the compound? Are you done with this? Saf, any answer?
1 minute, sir.
Okay. Alan, Mamuna,
Yes, sir. 1 minute.
okay.
Yes, sir, done.
Very good. What is the name of the compound? So what is the IUPAC name? As you know that this is metal, there will be positive, there will be negative. And here it is negative, here it is positive. So this will be attacking here and it becomes C double bond O, O negative. With the negative, positive will go. And here it comes pH. And after doing hydrolysis, you know that this H plus will be going with the negative one. And you will be getting PHC double bond OOH. Basically, you will be getting pH C double OH. That means benzoic acid you have got. What you have got? Benzoic acid. This is everyone. This is what everyone have got it. Yes or no?
Yes, sir. Yes, sir.
Okay. The next preparation is from acyl chloride and anhydride. Very easy. We just need to do the hydrolysis and you will get your answer. Like if you are having acyl halide and you are going to react this with water, you know that water has two parts, that is plus and minus, and this will have negative, this will have positive. X is more electronegative, so this will go, wait a minute, so this negative will go to the positive and you will be getting carboxylic acid in this. And if you have anhydride, you know what is anhydride. This is your anhydride. Again, you are going to do the hydrolysis. OH negative, H positive. So what will happen? There will be a byproduct, H and X combined to form byproduct this. Now again, this will have positive, this will have negative. So with this positive, this OH will go. So what it will be? There will be formation of what we can write RC double bond O, OH, and this positive will go with this negative. So there will be formation of another carboxylic acid, which are same here. So you just need to do the hydrolysis, break the bond, add the new component, and you will be getting your answer. Is that clear, everyone?
Yes.
Can you change the slide?
1 minute, sir.
1 minute. Oh, okay, I'm waiting. Just let me know. Are
Done,
you
sir.
done with this? Okay.
Yes.
Now see, you will be getting it by tomorrow. Can you see a new screen?
So,
Can you see it? Okay. So this is basically your what we say carboxylic acid in one page. First, preparation from oxidation of alcohols and aldehydes. You need to use a strong oxidizing agent. On this 1 degree alcohol, you will be getting carboxylic acid. Aldehyde, you will be getting this. And there is a list of a strong oxidizing agent. Then from the hydrolysis of acid derivative. So this will be basically your acyl halide and all, basic or alkaline, everything is given here, nitriles, from alkyl benzenes and everything. Are you able to understand it? Just look at this screen and let me know if you are having any problem.
what is CA here?
Oh, what did you just ask?
A CA in the hydrolysis of nitriles.
Wait a minute. On the right hand side,
Yes, sir.
uh, from hydrolysis of nitriles, are you asking, or
Yes, sir.
above it?
No, this one, sir.
Hydrolysis of nitriles.
Yes, sir. The CA part. No, I got it. I got it.
Oh, CA,
So it's carboxylic acid, right?
carboxylic acid. Yes,
Yes, sir.
it was just short. Okay. So there is whole property, basically preparation, and then comes your properties on the next page, this page, like this. Acidic strength, RCOH, if you are going to react with metal, you know that it will give you salt plus hydrogen gas. If you are going to react this with NHCO3, you will be getting, again, this is having salt, so it will be converted into metal. If you remember from class 10, acid react with sodium carbonate or sodium hydrogen carbonate, it will be giving you salt plus carbon dioxide plus water. So it's very easy, right? Is that clear? Now I'm going to change the slide. So after this, I want to discuss about the test paper. On upcoming coming Friday, you will have your aldehydes chapter, aldehydes, ketones, and carboxylic acid. After this, you will have amine and equilibrium, in which we will have chemical equilibrium in our test. Only these three chapters, not three chapters. This equilibrium is not the whole equilibrium will not be in our syllabus, because equilibrium has two parts: chemical equilibrium and ionic equilibrium. So in test there will be only chemical equilibrium, or we can say uh, up to whatever syllabus I will complete in class, that will be only in our syllabus for the upcoming test. Is that clear?
Yes, sir.
Okay. Now preparation is completed. Now we are going for chemical reaction. So chemical reaction of this chapter, especially this carboxylic acid, is very easy. So the first one, we are going to talk about acidity. Since it is an acid, so we are going to talk about acidity. And first we are going to react this. That means reaction with metals and alkalis. Alkalis, that means base. So you know that when acid react with metal, you will be getting salt plus hydrogen gas. So this is your RCOOH, and you are going to react it with 2Na. 2Na is only because of to balance it. So it will be converted into RCOONA, which is a salt, and hydrogen gas will be liberated. And if you are going to react this acid with salt, you know, acid react with salt to give you acid react with base to give you salt plus water. Salt plus water. So please do write it. And if you are going to react this carboxylic acid with sodium hydrogen carbonate or sodium carbonate, again you will be getting this plus H2O plus CO2. This reaction comes from class 10, which is very, very easy. So please do write it. Just let me know when you are done with this. Are you done with this?
1 minute, sir.
Okay.
Done, sir.
Okay. Now see, acidic strength, as we already talked about this in alcohol as well, which is directly proportional to minus I and directly proportional to minus M, inversely proportional to plus I, and inversely proportional to plus M. So if I'm going to give you a question like this, please do write it. Which one will be the most acidic? Arrange them in increasing or decreasing order of acidic strength. No, not A. See, NO2 is electron withdrawing group, and there is two electron withdrawing group. So this will be the most acidic, and it has only one withdrawing group, and this has only one plus I effect, which decreases acidic strength of this. So B, A, C will be your answer. Is that clear, everyone?
Yes, sir.
Saif, Mamuna.
Yes, sir.
Okay.
Yes, sir.
After this, reaction involving cleavage of, this will be your C double bond OH bond, but here we are going to break this bond, COH bond. Okay, so whenever this will happen, so we are going to study about formation of anhydride. Formation of anhydride. This is also a functional group. So as you can see, this is your carboxylic acid. We are going to take 2 moles of carboxylic acid in this way. And if you are going to break this bond, you just need to remove water. Then you will be getting anhydride. This is how formation of anhydride takes place from carboxylic acid. So please do write it. After this, we have the first one is formation of anhydride. The second one is esterification. So you know that when carboxylic acid react with alcohol in the presence of acid, you will be getting ester plus H2O. So how the reaction takes place? It's very easy. Always remember that you are going to remove OH from carboxylic acid and H from water. Sorry, alcohol. From alcohol. H from alcohol. Then you will be getting carboxylic acid. There is a question that has been asked about this. H plus is removed from carboxylic acid or alcohol. So this H plus in water, H from in water removed from alcohol. This is very important. And OH from carboxylic acid. Okay. Are you done with this?
Yes, sir.
Okay. The next reaction is reaction with CCl5, CCl3, and SOCl2. So if you are going to react any one of this from carboxylic acid, you just need to remove OH and replace it with Cl. You just need to remove OH and replace it with Cl, and you will be getting from this acyl chloride, again acyl chloride, and again acyl chloride. It's just like the reaction is just like the preparation of alkyl halide from alcohol. You just need to replace this OH with Cl. And with in this, the best preparation method is this only because these are in gaseous state. So in container, if you are going to prepare acyl chloride, this will be the best method because this will be evolved out of the container because it is in gaseous state. So please do write it. Let me know when you are done with this. Are you done with this? Farhat, Mamuna,
Yes,
Yes,
sir.
sir.
after this we have reaction involving COH group, COOH group. And this first one is our reduction. So if you are going to use a strong reducing agent like lithium aluminum hydride, or either you can use BH3. So this carboxylic acid will be directly reduced to alcohol. Like if you have ethanoic acid and you are going to use a strong reducing agent, this is your ethanoic acid, it will be directly converted into ethanol. So it will generally give you, primary alcohol, not secondary. So it's very important. Let me know when you are done with this. Are you done with this?
Yes.
Now the next is decarboxylation that we have already studied in the previous classes. Decarboxylation, that means you are going to treat this carboxylic acid with soda lime. Soda lime is basically mixture of sodium hydroxide with calcium oxide, and it should be in the ratio of 3:1. 3 is for NaOH and 1 is for calcium oxide. Then you will be getting RH. Basically, this will be eliminated. CO2 will be eliminated and this H will be connected with this. So you will be getting alkane or hydrocarbon. So if I'm going to give you cyclohexane carboxylic acid, and if you are going to use soda lime, on this, what will happen? This will be converted into cycloids. This all part will be eliminated and hydrogen will be added here. And you know that hydrogen, whether you want to show or not, that is not a big deal. So it will be converted into cycloalkane or cyclohexane. You can write. Let me know when you are done with this. Are you done with this?
Yes, sir.
Now, the next is substitution reaction in substitution reaction in hydrocarbon part. In hydrocarbon part. And there is a name reaction for this reaction. Basically, if you have RCH2, C double bond O, OH. So this part is basically your hydrocarbon part. This is your hydrocarbon part. So how we are going to substitute something in this part? This reaction is known as, before this, I'm gonna write a reaction for this RCH2. This is your hydrocarbon part, and this is your COOH carboxylic acid. And you are going to treat this. First, you are going to treat this with X2 in the presence of red phosphorus. And in the second step, you are going to do the hydrolysis. So there will be substitution of this X from this hydrocarbon part, and it will be converted into this. And X will be equal to either chlorine or bromine. This reaction is known as HVZ. That means basically Hall-Hard. Its name is Hall-Hard Zielinski reaction. Zielinski reaction. In some books, it is denoted by HVZ. The reaction is very important. There is a condition for this reaction. Alpha hydrogens should be there. So as you know that this is your main functional group. So this will be alpha carbon and it has 2 alpha hydrogen. So this X will replace or substitute alpha hydrogen. Always do remember. Let me know when you are done with this. Are you done with this?
Yes.
Now the next and the last reaction is ring substitution, and I want the answer from you. If you are going to react this carboxylic acid, I'm going to show you carboxylic acid in this way, or you can write COOH. This is your benzoic acid. And if you are going to react this with Br2 in the presence of FeBr3, then can anyone tell me what will be the product? You know what, this X2 in the presence of FeBr3, which is a Lewis acid, will generate Br positive. So basically it is electrophilic substitution reaction. It is electrophilic substitution reaction. Just wait a minute. This is your Br plus. It will generate Br positive. So can anyone tell me Br positive will attack at which position with respect to this COOH carboxylic acid? Can anyone tell me? Mamuna, Farhad, Iba, Alan, Hanifa, Aksa, Saif. So see, this Br plus will be adding. With respect to this, it will go at meta. Can anyone tell me why it goes at meta? Because this is minus M and minus M is your meta directly. That's why this Br will go at meta directly instead of ortho and para. Is that clear, everyone?
Yes, sir.
Very good. Okay. Let me know if you are able to see a new screen. Yes or no. Are you able to see a new screen?
Yes, sir.
Yes, sir.
So please do question number 63. The reaction that doesn't give benzoic acid as major product. What do you think? See, this is your primary alcohol. So in the presence of KMnO4, which is a strong oxidizing agent, it will give you carboxylic acid. It will give you carboxylic acid. That means benzoic acid. Again, this is your strong oxidizing agent. It will also give you COOH. Any answer? D. Very good. So if you are looking at D, PCC is a mild oxidizing agent, and if you are going to treat 1 degree alcohol on mild oxidizing agent, it will be converted into benzaldehyde instead of carboxylic acid. So B will be our answer. Is that clear? This will also be converted into carboxylic acid benzaldehyde with the help of NaOCl in the presence of H2. Very good, Hiba. Everyone got it? Yes or no? Saif,
Yes, sir. Clear.
This is a very important reaction that I haven't covered in the class because we are going to cover here. And this reaction is from NCERT and it is very easy. So if you have this dibenzoic acid and you are going to treat this with NH3 in the present and a strong heating is there. So first of all, what will happen? This NH3 will be attacking at this position because this H plus there will be uh, elimination of H plus from here and here. So there will be negative charge and there is a lone pair. So it will give NH3. This NH3 will give lone pair. It will make a coordinate bond with nitrogen or hydrogen, and it will be O negative NH4 positive. Again, there will be same COO negative and NH4 positive. And then a strong heating is there. That means 2H2O will be eliminated. That means you are going to remove 2H2O from here. So it will be converted into, see in which it will be converted. It will be converted into CONH2. So basically, I just removed H2O from here and H2O from here. So it is converted into phthalimide. And since you are going doing a strong, giving a strong heat, then you are going to again remove NH3 because a strong heating is there. And if you are going to remove NH3, NH2 from here and 1H from here, then you will be getting this product, which is very important. And this is a reaction from NCERT. That's why I told you to cover your organic and inorganic from NCERT. So this will be the final product. Please do write this reaction. Let me know if you are done with this.
So what's the strong oxidizing agent?
No, a strong heating.
No, the one you wrote after
Just
minus
wait.
2H2 and heat.
Are you talking about this?
Below it. This strong, right?
A strong minus NH3 I have written. After you are doing a strong heating, that means minus NH3 will be done. This will be written here. Okay.
Yes, sir.
Are you done? Everyone done with this?
Yes, sir.
Just wait a minute. I'm gonna give you another question. Okay. So the next question is this 67. Please do it. Question number 67, any answer? Let's see, okay, very good, Farhad. So see, we need to decreasing order of acid, trichloroacetic acid, trichloroacetic acid, that means CCl3 COOH. Trifluoroacetic acid, that means CF3 acetic acid is ethanoic acid. And then comes your acetic acid, that means CH3COOH. And then comes your formic acid, that means methanoic acid. So as you know that acidic acid directly proportional to -I or -M. So this will have the most withdrawing power. So this B will be the most acidic. And here it has written trichloro as A, then it is. And after this, if you are going to compare between this and this, you know, CH3 will decrease acidic character because it has plus I effect. So then comes your D and then comes your A. So the answer will be BADC. Is that clear, everyone? Is that clear?
Yes. Yes.
Now I'm gonna start here. The chapter is completed. Now I'm gonna start this equilibrium because it's quite a small and we will be covering this half part, chemical equilibrium. And in tomorrow's class we will be doing amines, so that we will be able to cover all the chapters of the upcoming test. So see, equilibrium has two parts. One is chemical equilibrium and another is ionic equilibrium. What is this chemical? It has been divided into two parts, chemical equilibrium and ionic equilibrium. So we will cover this after amines. Today we are going to cover this chemical equilibrium. Now see, this equilibrium is of two types, physical equilibrium and chemical equilibrium. Okay. Now equilibrium is also divided into two parts like heterogeneous and homogeneous. So what is heterogeneous equilibrium and what is homogeneous equilibrium? So in a reaction, first of all, in equilibrium, we see that it is represented by double-headed arrow. Double-headed arrow. That means it goes from reactant to product as well as product to reactant. That's why it will be shown by double-headed arrow. It is of two types, heterogeneous, homogeneous. Heterogeneous equilibrium is the one in which the reactant and product will have different physical state. Like you can see this reactant is in solid, this product is in solid, and this product is in gaseous state. So whenever there are more than one type of physical state in a equilibrium, that is your heterogeneous equilibrium. And homogeneous equilibrium is the one in which all the physical state of all the reactant and product is same. Either it is in gaseous state or either it is in aqueous state or solid state or liquid state. Are you getting my point? Mamuna, Farhad,
Yes, sir.
Alan, F. Now, equilibrium always carried in closed vessel, not open vessel. Why? If any one of the reactant or product is in gaseous state, it will be evolved out of the container, and then equilibrium cannot be balanced, or equilibrium cannot be achieved because one of the component is evolved out of the container. That's why we always carry the equilibrium reaction in closed vessel. Okay. Now the next point, which is very, very important. These are some characteristics of equilibrium. At equilibrium, concentration of reactant and product constant with respect to time. Let's suppose if you are carrying a reaction and after some time, the reactant concentration of reactant and product is not changing with respect to time, that means it becomes constant, then it is at equilibrium. Then the reaction is at equilibrium. Are you getting my point? If after some time, if you are seeing that the concentration of reactant and product is not changing with respect to time, then it is at equilibrium. Also at equilibrium, rate of forward reaction is equal to rate of backward reaction. Whatever is the rate of conversion from reactant to product, it will be equal to the rate of conversion from product to reactant. Is that clear? It will be equal. And here, when we talk about the concentration of reactant and product, it should be constant. Okay. Now, the third point is equilibrium is dynamic in nature. That means it is in motion. It always goes from left to right, right to left. Okay. And this is a graph for for concentration versus time. So you know that product started from 0 and reactant started from something, because we have something in our reactant. So that's why it is above and it goes down when reaction is carried out. So these 3 points are very important, and I have given 6 graphs on the basis of these 3 points, only 2 points, 1 and 2, and you are going to choose whether which one is true for equilibrium. If the reaction is at equilibrium, whether the graph is true or not. Can I change the slide? Are you done with this? No one is speaking at all. Mamuna, Farhat, Aksha, Hanifa, Alan, Hiba, Saf.
Yes, sir.
Now, read the question carefully. Which of the following are correct if reaction is at equilibrium? Let me know about this. Whether the first graph is true or not. Is it correct? Yes or no? And the graph is in between rate of reaction versus time. The one which is coming from the up to the down, that is rate of forward, and the one which is going from down to up, that is your inverse. One is what? Yes or no? First of all, we are going to talk about rate. So you just need to look at the rate. What it told us about the rate of forward reaction will be equal to rate of backward reaction at equilibrium. And you can see these are equal. That's why rate of forward is equal to rate of backward. And that's why it is true and correct for equilibrium. Now, when you are going to talk about this, you can see the rate of forward has other value, and the rate of forward has other value, and rate of backward has other value. That means they are not equal, so it is not true for equilibrium. In this case as well, you can see rate of forward has value this, and rate of backward has value this, and which are not equal, so it is not true for equilibrium. Are you getting my point? Saf, Mamona, Farhat.
Yes, sir.
Okay. Now, the next is concentration versus time. So I'm gonna take you here. Read about this. Concentration of reactant and product with respect to time will be with respect to time is constant at equilibrium. So if you are going to talk about this, you are going to check after some time, the concentration of reactant becomes constant, and here the product also becomes constant. You can see the time is increasing, but the concentration becomes constant. That means it is at equilibrium. Now here you can see again they overlap with each other. That means the concentration of reactant and product are equal, as well as they become constant as after some time. You can see time is increasing, but the concentration is same. That means this is also true for equilibrium. Now, if you are going to check the last one, which is also true for equilibrium, because after some time, you can see with respect to time, the concentration becomes constant, and hence there will be this is true for equilibrium. Is that clear?
Yes, sir.
Yes or no? Okay. Can I change the slide?
1 minute, sir.
No.
Sir, can you scroll up a bit?
Yes.
Yes, sir, done.
Now there comes a term that is equilibrium constant, and we denote it by Kc and Kp. There are two types of chemical equilibrium constant. Equilibrium constant Kc is for concentration and Kp is for pressure. When the reactant and products pressure is given, then we use Kp, and if concentration is given, then we use Kc. Now see, always remember that Kc, whether Kc or Kp, that will be equal to product upon reactant, always product upon reactant. Let's say if I'm going to write Kp, it will be written as, you can see what is the concentration of product. Let me write the term of expression for Kc. What is the product Hi? So I'm gonna write it in a square bracket, and this square bracket represents your concentration. And whatever is the stoichiometric coefficient, it will come in power divided by reactant. There are two reactant, you can see here it is H2, and what is the stoichiometric coefficient? It is 1. So whether you are going to write the power 1 or not, it doesn't affect. Which is the another reactant I2? So I'm going to write I2, and power is 1. So this is how we write Kc and Kp expression. For Kp, you are going to write in the same way. First, you are going to write the Hi. So since we are talking in terms of pressure, so I'm going to write Phi, that represents pressure or partial pressure of Hi raised to the power 2, because its stoichiometric coefficient is 2. Whatever is the stoichiometric coefficient, that will come into power divided by partial pressure of H2 into partial pressure of I2. Partial pressure of I2. Always remember that whenever reactant or product is in pure liquid or solid state, its active mass is 1. Active mass equals to 1. As you know that active mass is basically, we are talking about the concentration. And you also know that if something is in solid state, that is already highly compressed, there will be no pressure. So we don't write in terms of Kc and Kp when it is in pure liquid and pure solid form. I will take an example. First, write it. Are you done with this?
Yes, sir.
Yes.
Okay. Now see, if you have given this, let's say, if you have given this CaCO3 in solid state and CaO. So if you are going to write Kc is equal to concentration of CaO into concentration of CO2 upon concentration of CaCO3, it will be wrong. Because as I already told you, whatever is in solid state, you are going to ignore it. Its active mass is 1. So the Kc value of Kc will be equal to only CO2. As well as if you are going to write the Kp, you know that this is in solid state, so you are going to leave it and you will be getting only this. So this will be the expression for this reaction, and this reaction shows you that if any reactant or product is in pure liquid or pure solid state, you are just going to ignore it. Is that clear?
Yes.
Sir, how can we know if it's in pure liquid and solid
It will
state?
be written as liquid, it will be written as solid, like this. Are you getting my point? If I'm gonna give
Yes,
you
sir.
iron react with water, first of all, iron will be in which state? Solid. So mostly it will be very easy to understand, or either in reaction it will be given. So don't worry about it. Okay.
Yes, sir.
Let me know when you are done with this. Are you done with this?
Yes.
Yes, sir.
There is a between Kp and Kc. Relation between Kp and Kc. Kp is equal to Kc into RT raised to the power delta Ng. You know, this is your Kc. R is gas constant, T is temperature, and delta Ng is number of moles of gaseous product. This is your NPG, that means number of moles of gaseous product. Not we are not talking about aqueous, solid, liquid. You just need to take the number of moles of gaseous product. Now how you are going to recognize whether which one is what is the number of moles? So basically its stoichiometric coefficient is the number of moles, and this is your number of moles of gaseous reactant, number of moles of gaseous reactant. So if I'm going to give you an example, PCl5 is in gaseous state, gives you PCl3 plus Cl2. So if you are going to calculate delta Ng value of delta Ng, this will be equal to number of moles of gaseous state. So can anyone tell me what is the number of moles of product here? What is the number of moles of product? You can see one is here and one. Total number of moles of product 2 minus total number of moles of reactant 1. So delta Ng will have a value that is equal to 1. Are you getting my point? Yes or no?
Can you say again, sir?
There is formula written delta Ng is equal to number of moles of gaseous product. What is the number of moles of gaseous product? There is two product. You can see this is one because its stoichiometric coefficient is 1. Have you studied mole concept? Yes or no?
Yes, sir.
So can you tell me how many moles of methane is reacting with how many moles of O2?
1 mole of methane with 2 moles of oxygen.
2 moles of O2. So isn't it easy? Can you tell me how many moles of PCl5 is giving how many moles of Cl2 and PCl3?
1 mole of PCl3 and 1 mole of Cl2.
Simple. So total number of moles of product will be 1 mole of this, 1 mole of this. It becomes 2 moles of product. Yes or no?
Yes, sir.
And what is the number of moles of reactant? 1. So delta Ng is equal to 1 or not?
Yes, sir.
So if you have got the value of Kc, R value, you know that it's constant. Temperature will be also given. You just need to put the value delta Ng here and you will get your answer for Kp. Is that clear?
Yes.
Sir?
Yes, sir.
Okay. Can you tell me what is the value of delta Ng for this reaction? Very good. Delta Ng, what is the number of moles of the product? 2. What is the number of moles of gaseous reactant? 1 mole, 1 mole, 2. So it will be 0. Very good. Saf, any answer? Yes or no?
Yes, sir.
Saf, tell me the answer. Delta Ng for the N2 plus 3H2.
-2.
-2. Very good. What is the number of moles of the product? 2. What is the total number of moles of reactant? 4. So it will be -2. Very good. So this will be the delta Ng. Are you getting my point now? Yes or no?
Yes, sir.
Now, sir. Are you done with this?
Yes, sir.
Okay. Now see. Characteristics of chemical equilibrium. This is the last topic. Characteristics of chemical equilibrium constant. If you have a reaction A plus B, that gives you C, and its equilibrium constant is given K, and there is a question, they just reverse it. Just wait a minute before reversing. Now, there is a question. If you are going to multiply it by any number in the whole equation, and they ask you, what is the value of new equilibrium constant? See, it's very simple. There is a reaction for which the value of Kc is given. Now, the question says that if you are going to multiply with a certain number in the whole equation, what will be the new value of K equilibrium constant? So it will be equal to whatever is the previous value of equilibrium constant raised to the power number that is multiplied. So I'm going to take an example so it will be more clear to you if you haven't got it yet. So there is a reaction H2 plus half O2 that gives you H2. Let's say this is the reaction. And this has an equilibrium constant, let's say 4. Now, you need to calculate the equilibrium constant of this reaction. So if you look at this equilibrium, this reaction carefully, you can see this is your 2H2 and there is 1H2O. That means this reaction is multiplied by half. This reaction is multiplied by half. That means if you are going to calculate it, the K dash C new equilibrium constant will be whatever is the previous equilibrium and it raised to the power number that is multiplied. So it will be, is that clear? Is that clear?
Yes, sir.
Yes, sir.
Okay. The next. The next. If you have an equilibrium, if you have a reaction like this, which has an equilibrium constant K, and if you are just going to reverse this equation, the new equilibrium constant will be inverse of the old equation. So let's say with an example, PCl5 will give you PCl3 plus Cl2, which has equilibrium constant 8. So if someone asks you what is the new equilibrium or equilibrium constant for this reaction, you can easily recognize that it is reverse. So this will have K dash, which will be equal to 1 by 8. Are you getting my point? Everyone done with this?
1 minute, sir.
Are you done with this?
Yes.
Saif, Saif, are you there?
Yes,
Okay,
sir.
let's see. If you have a reaction A that is giving you B, which has a equilibrium constant K1, and there is a reaction C that gives you D. Just wait a minute, please. 8 minutes. Am I audible? Memona, am I audible?
Yes, sir.
F. Okay. So there is a reaction A that gives you B, which has equilibrium constant K1, and there is a reaction C that gives you D, which has an equilibrium constant K2. Now, what you are going to do, there is another reaction which has been given A plus C that gives you B plus D. That means basically you got this reaction with adding these two equations. So this will have a new equilibrium constant K dash, which will be equal to K1 into K. So that means if you are getting a new reaction from two or more other reactions, then the equilibrium constant of the new reaction will be equal to the multiplication of the all old reactions. Are you getting my point?
Yes, sir.
So please do write it. This is